He has expertise in spanning cloud infrastructure as code and DevOps practices as well. He has specialized in designing and resilient multi-cloud architects and automating complex deployment pipelines. He also has technical foundation, which include extensive experience with AWS, GCP, and Azure, that is multi-cloud, complemented by multiple cloud certification. So, ladies and gentlemen, please help me welcome Alvin. Alvin, if you can hear me, the screen is yours and the mic is yours. Karibu sana.
Thank you very much, Nelson, for that warm introduction. I'm really grateful. I'm also grateful for the opportunity to pass on the knowledge. And yeah, I hope you get to learn a lot. Disclaimer, before the demo started, I wanted to check out if things are running properly. So I broke something in the EKS. So unfortunately, we are not going to see the EKS demo, but I'm going to demo all the other parts using Terraform. So yeah, I'm sorry for that. Okay. Can you please allow me to share? Elton.
Yes. Just a moment.
Okay. Thank you.
Right.
Confirm you can see my screen.
Yes.
Okay. So before we begin, I'll just give a breakdown of how I've structured the Terraform itself. So because we are going to discuss about enterprise, we are going to look at how enterprise structures its Terraform so that we can have quick go-to-market, because your work or my work as the DevOps engineer is to also speed the development and also the client's go-to-market strategy, since they are going to need this to have the ROI for the entire project. So before we begin, I have the main file, which we do have a VPC, an EC2, and a security group. And as I mentioned, we would have done the EKS, but I broke something within the policies. So unfortunately, and I don't think we can have time to fix that, but that is the structure of the main. So this is the first file that is going to be called before you do your plan. Okay, let me talk about the other files first of all. We also have the backend, which now specifies where you're going to store your state file, because in production, it is advisable to store your state file within an S3, and also have the dynamo for the state lock. But you no longer need this because from version of Terraform, I think 1.10, you can have the automatic state lock on S3 itself. But this is a practice that I still carry forward. The other file is the providers, where I specify my Terraform. You can also specify the required versions. It's just that for a POC, I did not go in depth to specify a required version. For instance, you can specify that you don't want to use anything less than the version 6 of it. And the provider, which specifies the credentials that are going to be used to deploy the entire infra. So before we even do any other plan, I'd like to mention some of the hidden costs that are seen within organizations. And the first one will be the drift and bottlenecks, because a lot of organizations have big infrastructures, and as a team, and you don't have a central point of managing your infra. And let's say you do something ad hoc, or using the CLI, or when you do ClickOps, the first one is the tax on drift, because it becomes a bit hard to manage that drift and to know what happened. And also, because these are regulated industries, it becomes a bit hectic to answer questions from an auditor. For instance, someone changed the security group, and no one noticed within the organization, and the audit was done, and they found that the security group was changed, and no one can be accountable for that. So the first thing is to always ensure that you're managing state from either from the backend itself, or you can use the Hashicorp Terraform itself. They provide for you a place to also store state, which is good because it has a concept of workspace. The difference with workspace and how most organizations, or how I've kind of done it, is I've used the file structure instead of using the workspace themselves. So just know that you have an option of using workspaces. So these workspaces can be good because they can offer you the ability to give permissions, let's say read, write, or execute only within those workspaces. So it's a bit tied. I'm not saying that this doesn't also cover the same permissions, but it covers those permissions from a repository level, whereby you have to ensure that you always have a workflow that is doing the pushing to production, and any other kind of environment can be done manually using the CLI, which we are going to do. Yeah, unless there is any other question. Sorry, if there's questions, you can bring them. So the other thing that we should know about Terraform is the flow of Terraform, which is the first we do the write, then the plan. Then for organizations that are heavily regulated, we do have the policy check. So this policy check happens before the plan or the apply is ran, so that the security is done towards the shift left. So something like Sentinel or the OPA can be used to inspect this Terraform before you actually do the Terraform apply to the organization's AWS account. So the last and final step is always the observe, to observe if what you're actually deploying with Terraform is what you actually expect. And the other thing that we tend to mix a lot is what Terraform is and what Terraform is not. So before even going deeper, I will also like to mention that Terraform is not per se used to deploy applications. I'm not saying that it cannot, it can, but with large organizations, you have to separate your life cycles into layers, and I'll cover more about those layers as we go on. So the other thing with Terraform is that it does not configure your operating systems or VMs. Note that I'm not saying that it cannot, it can, which we'll see with this install here, which can basically do the same, but kind of ad hoc and needs to be run all the time through Terraform. The other thing is that it does not manage Kubernetes workloads natively by itself. You have to add on some Helm or do the Terraform Kubernetes bridge to bridge some of the gaps. Um, I'll show you that in a bit. So I believe I've covered how state management is covered by the S3, the Dynamo, and also the other alternative for organizations is the Hashicorp Terraform Cloud, which is also an option that I mentioned previously that has the concept of workspaces. Yeah. So I'll cover a bit of what is in a single module because the whole concept of Terraform is to create reusable modules that you don't need to necessarily have the engineers rewriting rather than they can consume. And the only thing that they need to keep on changing is the variables. I prefer using the variables.tf because it's a bit more secure. I know the option of the Terraform.tf bars. So the challenge with this is that yes, it's good for the pipeline, but it's bad for compliance in that some of the variables in Terraform, or no, let me not say some, but when you have variables in Terraform, they are stored as plain text. Even if you do have the sensitive keyword, they can still be visible. So the best practice is to have, let's say you reference a variable from the SSM itself, which is the secret store on AWS, rather than having the variable passed here directly. So the other advantage of that is I can start with this default, but then I have the option to go and rotate this variable within the AWS agent itself. So I don't necessarily have to do the Terraform each and every time, but that is something that you have to discuss internally because you see there are two different kinds of life cycles there. So the first one is anytime you go and rotate the keys manually, the keys that are maybe here on Terraform and also in the state file itself are different than what you have. So that is something that you do have to discuss and how you're going to manage that going forward and also have that documented so that it's easier for you to onboard a new team member and for that kind of continuity. Because also remember the factor of speed is also looked at within large organizations. So they are going to ask, since it's Terraform, why is it taking a bit of more time to replicate? And yet we know they're done in modules. So this is something for you as an organization to have that policy internally. But best practice is to have any kind of sensitive variable inside of the KMS or the SSM, whichever. Different organizations prefer differently. Yeah. So the main, each module has its own main. You can name this however you want, but because of uniformity, I like specifying it as main. So this is the one that is going to specify the resources that you want to actually provision within the AWS itself. As you can see there, specifying the VPC itself, the subnet. And let me just do this. Yeah, you can see I'm specifying the VPC ID for creating the VPC, the map on launch to create a public subnet. Um, This is also something that I wanted to show within Terraform, but no, sorry, within EKS, but unfortunately you will not see. But the reason this is shared is because a lot of organizations have shared infrastructure within a shared workload account. So you'll find that there's a lot of shared resources or accounts. So you'll be told to create this uh, subnet within a shared workload account. So you also have to specify this tag so that Kubernetes itself can also have that shared tag, so that when you're doing anything within Kubernetes, it does not override the shared tag itself. So this is also something important. The other things are just other basic configs for the route table. Yeah. So I remember mentioning that within Terraform, you cannot create, or rather, you cannot use it to provision VMs, which is kind of true because Ansible is much better at that work, but you can have this user data to do that kind of bootstrapping, because it's also possible to do it when you are doing it from the UI. Um, So basically, I am recreating this step. I know most of you, yeah, this last final step where you want to configure your, let's say, Ubuntu instance to have the SSM agents, so that you don't have to keep on going inside of the the instance after boot up. So you would just add the same kind of script, but yeah. So let me copy this. Also, I do know that I have created a VPC. So something else interesting when you break down the Terraform into modules is that you can be able to create one module at a time, or all the modules, depending on the change that is needed. And that is good. For instance, let's say you changed something within the security group, and that change might affect something within the, let's say, EC2. You can only run the SG uh, module on its own without triggering all the other modules, because Terraform's behavior is to delete then recreate. But it is smart enough to know that I should not delete what was already existing. And we also have another concept of life cycles within Terraform in production. So you don't want this cluster to get deleted by mistake. So let me just show you. Okay, yeah. So you can be able to add the life cycles to, let's say, prevent, destroy, and set it to true. So what this does, it will ensure that however much this Terraform is run, the cluster will not be destroyed by that delete. So this is also something to note when you want to prevent the destroy behavior with Terraform. It can be applied with maybe an individual or all of them at once if you prefer. So that is also something to maybe have a discussion internally, so that you can align on how that is done for also business continuity, because that is also part of our role is to ensure that the business continues even during the downtime, so that the customers cannot kind of, maybe I don't want to say feel the entire downtime, because I know at one point or another we have all experienced that, maybe with our M-Pesa or maybe a different kind of banking app. But Terraform is actually there in place to kind of help with also that kind of management. That is now falling under disaster recovery. So different organizations have that set up differently. You can do that with Terraform, or have something like an active active or active passive, and that is done with Route 53 and different kinds of failovers. But anyway, we can talk about that some other day. So remember earlier I mentioned that you can do a specific module at a time. And because I already created my VPC, I'm going to create the security group, which I do have specified here, as you can see. So I'm only specifying for 80, 443, and a React application, which I do have outside of the modules. You can note that also this can be structured in any kind of way you want. This doesn't necessarily have to live inside of the infra. This can live with the development team and have its own even repository, to have its own GitHub actions and its own pipeline. You remember I said we do have life cycles. So the first life cycle, which is owned by the platform team. So you can think about this like the VPC subnets, the transit gateways, the VPC, the zones, the shared IAM roles, the centralized logins. Then we do have the other layer, which is the application layer, which is now owned by the dev team. So that is done in order to have a kind of abstraction from the development team and the infra team. This is also good in these kinds of setups because it helps with the kind of cognitive load that is there on developers. So we don't want to onboard you as a front-end developer and have you looking at the infra kind of setup. It might be a bit overwhelming. So we do have that separate. So I'm saying that this looks a bit small, but in large organizations, you can imagine we do have 50 modules. Some are shared, some are not shared. So it's good to have that kind of separation and that kind of layering. So the other layer now comes under the shared services. So this can be owned by the platform or the SRE team. So this can be things like the EKS cluster, the RDS, the uh, Elastic caches themselves, the registries whereby the images are deployed. Because again, remember that security within an organization is quite strict, because we do have a layer of scanning the images before they're actually deployed in the ECR itself and not the EKS itself. So that is also why we do have that kind of layering approach. And so those are three layers: the platform, the platforms, yeah, and the platform and the SRE, which is shared, and the other layer is now the application. So the three layers. So how do we now share those layers within Terraform inside of big organizations? So we do have Terraform remote state. So unfortunately, I can't share that. It needed me to have another team which yeah. So there's that Terraform remote state which you can use to share the the resources between those layers, and you can also have them within the SSM parameter store. That is something that you can discuss within the organization and have it known where it's stored for also continuity. Because the other challenge is that when these things are done in silos, it becomes hard maybe when you're onboarding or maybe when the engineer left the organization and the other team members have to kind of figure out where this was stored and where that is. Because the other challenge is we do a lot of Terraform, but when you ask for documentation, you just know how it goes. Yeah. So I think I can do this. I hope I didn't also break the.
Kabwa anaingia kuuliza.
So I don't know.
Kindly TJ, kindly mute yourself.
Thank you. So I do know that for a lot of before you do actually what I've done, it's actually good to do the plan, which I know a lot of you guys have done. So for me, I've just done this because I went through the build before we actually came to this. So let me see. And yeah, you can see, so I was able to only create the security group. We can also validate by, let's see if it created the EC2. So you can see we do have the ability to create a single module at a time. So we can now maybe have the EC2. So I just have specified permissions within the EC2 module itself, but it's good practice to have all these IAM permissions specified within a module for the IAMs. So, but again, this is also something that can be discussed internally because it also comes with a management cost, not a cost on AWS, but the overhead management cost on the engineers themselves, because some would prefer to have their own policies within their own modules. Because again, remember, you can break this down either per engineer or per feature or anyhow, depending on how your organization is structured. Remember, a lot of this is driven by the structure of the organization itself, because the organization is the driver of the platform itself. So within us internally, we usually have the platform team act like the customers, so that we can give the SRE team kind of where to improve. Because remember the three layered for the structured. You own the platform, the SRE is responsible for uptime of the application. So you have to act like the customers so that you give the SRE team feedback on how the platform is let's say, behaving. Is it fast, slow, the latency and all that? So that is good to do internally so that you get to detect any kind of issues before it even gets to the customers. And depending on how you structured your BDR, you can kind of recover quick if it's on Terraform or if it's the Route 53 route. So that is an option to also discuss internally. So for me, I do have them per specific module. As you can see, even the EKS itself has its own specific policies. So this is just practice so that you also don't give overly permissive permissions to the resources themselves. Remember to follow the least privilege because uh, anything can be kind of used for an attack. There's kinds of lateral movement from within the cluster itself. So if you didn't give the cluster enough permissions, let's say giving few people root or admin within the cluster, or even kind of having policies within the cluster itself so that you prevent escalation from the node itself into other components on the AWS, because once you compromise the node, you can be able to reach the RDS. If the application is using RDS, you can be able to reach all the other kind of components that are being used. So this is just practice that I do follow, as you can see. And also specifying the OIDC. But what would have been interesting for us is how I use Terraform's null resources to maybe provision something like the AWS load balancer controller within the EKS itself. So this is something that you can do with the null resource. I know that there is not much need for this because of the, let's say, DevOps agent, but for me, this kinds of gives me a bit of more control, but it's kind of give or take because the other one comes with a bit of more advantage, like helping with debugging and all that. But for this, it's manual. But the thing that I'm trying to get at is that you can use it to actually install components within your cluster. I think I used it to install Cilium. Let me see. Yes. Yeah, so as you can see, I'm also using it to install the EBS CSI driver. It's also being used to install Cilium. So this is also something that I would have liked to do a bit of demo on because it it kind of it's I'm not really trying to sell the tool, but it's a really amazing tool for what we use it for, because we do have some clients who are on multi-cloud environment, so they're on AWS and they also have their kind of on-prem setup. So the other question becomes, how do you manage your IP? So this is IPAM management on Kubernetes and also on AWS, which is a bit kind of different. So let me just go slow and say that IP management will end at the node group once you've specified the VPC CIDR block. So if you get now a client on the on-prem and they do have, let's say, an overlapping CIDR block, or you don't want to have less IPs for the workloads, because also your workloads will get the IPs from this, because Cilium does offer 3 modes for IP allocation, that is cluster pool, multipool, and forgotten the other one because I rarely use it. So you can use this to extend your number of IP addresses. So it can be used to add another CIDR block on top of the already existing one that is offered by AWS. So yeah, we would have seen a bit of interesting stuff with this. The other thing to note is that when, let's say you try this on your own, you need to make sure that you disable kube proxy, because it's going to interfere with how Cilium works on AWS. Yeah, the other thing that it installed using the null resource is the Tetragon, which is used by the cluster for hardening. Remember, for a lot of these organizations, they are really heavily regulated. So this is used for security during runtime processes. You want to see what kind of process or pod opened, let's say, a file or a network path or any kind of thing that happens at the runtime level. You can be able to trace and also have, let me see if I have them. Let me see. Nah, unfortunately. So where? Yeah, these are the Cilium networking policies that I was telling you about that can be used as an additional layer of security. Remember that Kubernetes by default is flat networking, so that means that anything can talk to anything within the cluster. So it's for you to specify what can speak to what. And I had this here to show that it can be automatically deployed by Terraform. Let me see if I have attached them somewhere. So I think that is what I broke, and it is what I wanted to show. I think I broke that. But anyway, you do have the ability to deploy everything at once. So when you run this Terraform, it will build for you the cluster and deploy for you the networking policies within the environment itself to make sure that because you are regulated, you meet the compliance standards. You also have to meet our own here within Kenya, the Office of the DAP, the ODP, yeah, the data protection. So for a lot of these heavily regulated industries, we do have to have a lot of this. Maybe the last one I can mention is the Argo CD image updater. So what this does is it will automatically update for you the image tag itself of the application that you want to push, because remember, you want to have something that meets compliance and is auditable. So this gives you that you can be able to show the compliance officer that, hey, we are compliant in this way, that this is what we have and this is what was pushed, because you get an actual record of this that can be seen and traced, rather than the tax drift that we spoke about in the beginning of the session. The other thing to note is, because a lot of organizations are on multi-cloud environments, this structure is also good because you can also add your other provider here, where I think it's Azure. Let me see. Doing it wrong. I know you are able to do this. Yeah. So I can be able to add this and come and maybe specify a different kind of So it depends on how you structure it internally, because this can live within a different repository and it's consumed. Let me see if I can show you a sample of that. Just a moment. Let's see if I can find what I mean. Give me a moment. Okay, yeah. Okay. What I mean is that you can be able to consume, let me call it what ks, and have the source. Just a moment. So what I meant was it is also possible for you to reference a module that exists within a different repository. So something kind of like this. Just a minute, let me see if I can get um, so I think I've lost it in my documentation, but it is actually possible to reuse modules in this kind of way. And it is also possible to reuse them if they are in a private repository. The beginning at this point will be a bit different if it's in a private repository, but it is possible to actually do that. Yeah. So I believe because I killed this. Let me see if I have anything. Oh yeah. So I also wanted to demo a bit of Carpenter, because it's also used within large organizations, and it's tied to Kubernetes, and it's also good in that you don't have to do the bin packing yourself. So bin packing is, what that means is you need to find a way to actually pack your applications in appropriate instance families because of also cost management. So think about it like you as the engineer thinking about, where am I actually going to place this? Am I going to use a T3 micro, T3X large, that kind of thing? So Terraform is smart enough to do that for you. So it saves on costs when you're in a large organization. So you can specify and create, and then it will do the bin packing for you automatically. So that means that for instance, your application can be spread across these instance families depending on how it performs. So it will not necessarily run all the time on a T3X large. So it does the bin packing for you. Yeah. So I believe maybe I can give it back to Nelson, unless there are any questions. I think we can't.
Well, that was quite fun, Alvin. I've also learned two or three things. I think there's a question here from Best Band. Quick one. He's asking what is your opinion on splitting workload provisioning, that is Helm and kubectl, from infra provisioning as some enterprise do.
So the question I'm getting is that what is the benefit of splitting the two? So that
The
can
benefit
be.
of
Sorry?
splitting. Yes, he's asking the benefit of splitting the workload.
Yeah. So remember in the beginning, I mentioned something to do with life cycle management. So lifecycle management falls under the three layers that we spoke about: the platform team, the application team, and the shared layer, which is shared between the SRE and the platform. So this is structured in a way that creates independence from the application team and the platform team, in that I give my developers the ability to create their own resources within AWS to reduce the number of tickets that I do have to deal with. So it is also an kind of trade-off for you as the engineer to kind of think about the trade-off. Which will you rather do, to give the engineers the kind of self-service ability, or you as the engineer having to deal with all these tickets that come from the developers? So this can also go a step further into building something like an IDP into your platform. So this is an internal developer platform tools. So they are kind of overkill management tools like Backstage or IDP Builder itself, which is supported by Kubernetes. So that gives you the ability to provision everything and just have the developers come and just start coding. Everything is provisioned by Backstage or the IDP. So the developers just start coding without needing a lot of onboarding onto your platform, because you can find that some organizations will require you to do the coding on their platform or access it through a kind of VPN. So that is a practice. So to kind of have that different kind of lifecycle management, and also to make life easier on yourself as an engineer, so that you give them that ability of self-service. So remember that that is also a choice. It's not only the technical, it's also on you as an engineer. How much willing are you to be dealing with tickets and all that? So that is also a trade-off you need to consider, and also an internal policy. Yeah. So I hope that gives an answer.
Yes, thank you, Alvin. I think there's also another question. Um, he's asking, I think it's something to do with versioning. Just saying, I'm curious, using this structure, how do you handle versioning for the modules? For example, when introducing a breaking change in an upstream module that is used by other downstream module resources.
Nice, nice. I like that. So the first thing that we usually do is we have CSPs within the organization. So this a CSP is a service control policy that states that each bucket that is created within the organization needs to have versioning. So versioning from the S3 bucket is good because it helps us to kind of roll back to the previous version in case of breaking change. So we do enforce the S3 versioning at the organization level, because also we do have a CSP that specifies that all states should be within a specified bucket and also there is also a CSP that should be there to kind of guarantee that the application should only be pulling those, let me say, the images themselves from certain kinds of repositories. So that is to say that you cannot pull an image from the AWS ECR if that image is not tagged. So we do also have policies in place to specify that images should not come to the ECR unless they are tagged. But there is ClickUp, so we cannot kind of have that done through and through because someone might have that changed by ClickUps. So we do ensure that before that is pulled, it does have some certain criterias. So for us, we do heavily rely on versionings. But remember that I did mention the Terraform cloud is also an option, though it's, I think, paid but free up to, I think, uh, five, five users, if I'm not wrong. So you can have the ability to test that out. So yeah, I hope that kind of answers the question.
Yeah, I think that is well explained. And even the aspect that you mentioned of locking the S3 bucket as well, so that when you are having a team of developers, when you are doing Terraform apply, you don't
Yes.
have the drift of the infrastructure, so that your infra
Yeah.
cannot be corrupted. So I think thank you so much, Alvin. I think you have covered so much of it, and making complex things look a bit simple with just explaining to it. Just want to thank you because this was a short notice, but you made your time to even. I know we had talked with you on Friday. The session was supposed to be on Friday, but on Friday you had a go live. So thank you even for scheduling your busy time. And even you 19 guys who have come here to support us, I thank you so much. I know you've learned one or two things. In case you'd want to maybe link up with Alvin, I think he's also in the Terraform group and he's very supportive. He's also part of the community and he's always willing to support us as well. Probably if there is no question, I would just want to mention that we are doing this is the last week of our 30 days Terraform challenge. And guys, congratulations for those who have made it this far. I think there will be communications that will be made this week because we are supposed to have a wrap-up event on 18th. We'll communicate the other details in the due week. It's supposed to happen on 18th, that is on Saturday. And stay on the loop. I know there are some things that will happen this week. And I just want to even thank you, each and every person who has been here. I look forward to catching up with each and every one of you. And I don't have any other thing to say. I can see Alvin is already destroying his infra. Actually, was about to tell him that. Yeah, so I just want to wish you guys a good night. Not unless there's someone with anything to tell us or anything or question. We would want them to ask this moment. Please, if there's any question, you can just unmute yourself.
I would also like to add that you can also use the .github to check for drift, because you can have your custom pipelines within the GitHub itself to check for that. So that is also quite possible. You create a workflow for that You remember in the beginning, I mentioned the shift left for the pipeline before anything is actually deployed. So that includes something like the OPA and Sentinel at this level. So you can also add your own custom checks to the .github itself at the workflow level. Yeah.
Yeah, that's awesome. I think what you can do, Alvin, is you can push this code to GitHub, and then maybe you can share the repository either on the group or you can also share with me. I'll share with the rest of the team.
Yeah. Let me share. I think my personal. Just a
Yeah,
minute. Let me just share with you my
okay.
personal.
Yeah, so there's someone who is asking,
Mhm.
this is Midega George. Alvin, did you remove the GCP provider that you started creating? That's where I think the issue comes from. Oh, yeah, there was a provider that you created for GCP, the
Oh,
providers. Yes, yes.
thank you,
And you
thank you,
can comment of
thank you.
that. Yeah, yeah. Oh,
I
it
was
was actually
wondering.
growing.
Thank you for that. I do actually have uh, more projects on my GitHub on this. Let me share. Where is this? I'm putting them in chat.
Right now.
Um, so that is one of the projects that maybe you can look into. It's structured, has the modules. Feel free to also look at all the others that are there. Most of them are Kubernetes. Uh, yeah. Uh,
Awesome. Um, I think if there are any no other question. Do you have a question from the team? All right. I think we'll end up there. Thank you so much, guys, for creating time. See you on the next one. See you on Saturdays for those who are going to show up. Thank you so much, Joel. I also see Effie and all the other members who have joined this session. Thank you so much. On to the next one, guys. Asanteni.